Hello, everyone. Here we are, Ike and Jan from the research team for this AMA about the token module, the last blog post about the token module. Before starting, we want to check that the audio, the video, everything is okay with the streaming. So as usual, we are going to be here making that sure for the next 1 minute or so. And when we are all good, then we will start with the AMA and with your questions.
So please just write in the chat box if everything works all fine, then we can get started.
Okay, one person stated everything is good and sharp, another one as well, all good, Monica as well. Then have fun.
All right, I think we are all set.
Yeah,
then.
Yeah, it looks like everything is working as expected. So as I said a minute ago, here we are, Jan and myself, Iker, both from the research team. Yeah, and today we have this AMA to talk about the last blog post of the interoperability series blog posts. This one was about the token module that Maxime was the author. Unluckily, Maxime is not here today, but we will try to as he, like the real author, was here with us today. And yeah, that's it. So any question regarding the last blog post, the token module, anything regarding interoperability, our current research, whatever, all these questions will be welcome. And I think that's it for the introduction. So now Jan will have a quick overview, summary of the content of this blog post, and then we will start with the questions.
All right, thank you very much, Ika. Yeah, just to so that everyone is on the same page, I just want to quickly summarize the blog post for everyone which maybe didn't have the chance to read it or just who skimmed over it. So the blog post is called a new token module. And maybe you're aware we already have a token module in the current SDK and which is running on mainnet. So you may wonder why a new token module. Well, for this, there are several reasons. And the main three reasons are the following. The first one is that now with interoperability, and different chains interacting, we want to support not only one token per chain, but arbitrarily many tokens per chain, which can originally come from your own chain or possibly also from other chains. So currently on mainnet, if you do a balance transfer, you never have to say which token you are actually transferring, because it's always clear it's going to be the Lisk token. There's only one token. And in the SDK, the functionality, if you use our token module, is also the same. You just, it's assumed to be this one native token of this chain that you transfer. And with this new token module, you now additionally specify which token you actually are transferring. So this is one thing, that this new token module supports multiple tokens. Then this token module adds cross-chain functionality. So you can not only transfer tokens within one chain, but also to other chains in the ecosystem. So there's a new kind of transaction that allows to specify a target chain, and that allows you to transfer tokens also to other chains and to accounts on other chains. And then the third main new feature of this token module is some kind of better encapsulation, you could say. For example, now the token module supports locking and unlocking tokens. And this way, if you use a token, you can be less concerned that if there's some issue in your code, that you by accident inflate the total supply of tokens just with a very small bug, because the token module will ensure that no tokens are created out of thin air or destroyed unless you really call the respective functions to destroy tokens or to mint new tokens. So then there are also a few examples, and the first one is in this blog post. The first one is Depos, and in this example, it's also explained that the Depos module can in the future use this locking and unlocking. In the current mainnet, it uses actually debits and credits tokens, which means that the Depos module stores balances in between, and then once you unlock them again, it credits them back to your account. So in the future, this will be handled slightly differently, like in the blog post, that you call the lock and unlock functionality of the token module. And this way, also for other use cases, you're really sure, even if you mess up, you wouldn't inflate the total supply. And yeah, just to shortly mention, then there are also two other examples in the blog post. Maybe if you haven't had the chance to look at them, check them out after the AMA. One is about HTLCs, how to implement HTLCs with the new token module. And one is about a concrete use case, which is called loyalty points, which is basically, you can imagine there's a small business which wants to give their regular customers some loyalty points, and that the customers can then redeem later, yeah, maybe for a coffee or whatever that business is. Yeah, so this is just a brief summary of the blog post. I think then we could get started with some questions.
So maybe I take the first one, which is quite specific to the blog post, the content of the blog post. It says, in the example of the figure 3 in the blog post, could I send token A from chain B to chain C, and how will that work? So let me check. Yeah, so in the blog post here I have in front of me, we have this little example ecosystem, right, with the main chain in the middle, as usual, and we have three chains, chain A, B, and C, and there is a token A that is like somehow flowing the ecosystem, right? That's the example of the figure 3. And in the blog post, we see that the token A is being transferred from chain A to chain B, from chain A to main chain, from chain A to chain C, but it says we cannot transfer this token A from chain B to chain C. And yeah, so it says like, why? The motivation behind this is because something that also Jan was mentioning, now we have this way of maintaining so in the whole ecosystem that the supply or the amounts of certain tokens are consistent in the whole ecosystem. And this is done by this escrowed account that in the blog post is somehow introduced, right? Like each of the chains have an escrow account of their native tokens to keep track of how many tokens are going to certain chains and so on. So that's the motivation why we cannot do this direct transfer from chain B to chain C. But of course, I mean, here is that it doesn't say in the blog post, but of course, in general, we can transfer token A from any chain to any other chain. The problem is not directly. So as maybe you can assume already, what will need to happen here to transfer the token A from B to C, since directly cannot happen because of chain A needs to be aware of the movements of this token A in the ecosystem. First, the chain B will need to send token A to chain A. That's as we can see in the example, this is allowed. And then when we have the token in the chain A, we can already send it to the chain C, as you can see also in the example that this is allowed. So for when a non-native token is sent from two chains that are not the native chain of the token, we'll need to do always the detour through the native chain for this to happen. And this is, as we said before, is the reason is so the chain A, which is the chain native to the token A, it will keep track of how this token A is, how it is spread through the ecosystem and knows like chain C has this amount of token A, chain B has this amount, and so on. So that's the reason why we cannot have this direct transfer of token A, but it is still possible with the detour through chain A.
Yeah, maybe just to shortly add to this. So the reason why you go for always via the native chain, like all cross-chain transfers have to go either from or to the native chain, is really security, as you Ika mentioned. And so that the native chain, which is chain A, maybe an Oracle chain with an Oracle token, can always do the accounting, like how many of my Oracle tokens are in which chain in the ecosystem. And if I do this accounting or this escrow, then I can ensure that no chain could inflate the total supply of my Oracle tokens, even if like the majority of this other chain is malicious. They could never do this because I do the accounting, and if I know 1,000 tokens went to this other chain, then I only allow 1,000 tokens to come back. And this ensures that other chains cannot mint my native tokens.
Okay. What about this one for you, Jan? See here another question. Like now you just mentioned the function mint, right? This expose function mentioned in the blog post also. So the question will be, what will happen if my custom module tries to call this mint function in a chain that is not the native chain of the given of this token?
So the token module ensures that you can't really do something illegal like this, because as we said, only the native chain should be able to change the total supply of a token by minting or burning tokens. And this is really ensured by the token module. So if you use this token module in your chain and you would try to call mint on a token that is not native to your chain, it would fail. So the transaction which calls this API of the token module would just fail. So as this is not allowed.
Yeah, I mean, like it's very simple, right? I think the function first will check if the token ID, right, of the. So we are calling the mint function and passing the token ID of the token that we want to mint, and in the token ID we have the information of the native chain as it's explained in the blog post. And if we see that, well, if the function sees that the native chain is not the one the native chain given in the token ID is not the chain in which this function is being called, then it fails.
Yeah.
And that's as simple as that. Yeah, and as we were saying before, right? This will be for the token module, and if someone maliciously or by chance modifies the token module, this situation or this issue will be restricted to the chain where the token module is modifying, because the token module shouldn't be modified. That's the main point. But if it happens, the issue will be restricted to this sidechain, as we said before, because of this escrowed and accounting of every token in the ecosystem. So yeah, even if someone wants to, like, okay, I will modify the code explicitly to be able to call this function outside in a non-native chain, this shouldn't be a problem for the whole ecosystem. Of course, in that given sidechain, the user should be aware that it's running something else that is not a token module anymore.
Yeah.
Yeah.
Maybe as you shortly mentioned this, to explain this token ID, it's always the concatenation or part of two values, which is the chain ID. So every chain in the Lisk ecosystem has a unique ID, and then a local identifier. And so if you have, let's say, an Oracle sidechain, which may have ID 3, then the first native token from this chain maybe has local ID 1, the second one local ID 2, and so on. And if this token would be handled on some other chain, and you then see this token has chain ID 3, but the chain ID of my chain is chain ID 5, then you know this is not a native token.
Yeah.
All right.
So I will take the next one, just a bit longer one, but I think it's interesting also to clarify some concepts of the token module. So the question says, if the Lisk main chain only supports or keeps Lisk tokens, right? That this is, I think is mentioned in the blog post and in the lib that the Lisk main chain, the Lisk token is the token native to the Lisk main chain, and not only is the one native, but it's the only one and the only one supported, that there cannot be any other custom tokens in the Lisk main chain. So yeah, we know that. So given that situation, what will happen if I send my custom tokens to the main chain? And then, okay, there's a follow-up question. Also, how can I transfer custom tokens in the Lisk ecosystem, knowing that every cross-chain balance transfer has to pass through the main chain? Okay, that's okay. The first one, let's go in by parts. So if I send my custom tokens to the main chain, two things can happen, right? The token module have this functionality that if first, this would be a mistake by the user, right? It's like just the user should be aware that you cannot send tokens to the Lisk main chain, but imagine something happened or it was a custom logic that didn't work as expected, and suddenly the custom tokens were sent to the main chain. So two things can happen. First, if the cross-chain transfer sending this custom token was paying enough fee, and in the lib you can see what is what we call the minimum return fee, right? In the cross-chain message lib that we were commenting in the last AMA. If it has enough fee, so a fee above this minimum return balance, this cross-chain balance transfer of the custom token will be returned back to the native chain, saying like, sorry, this token is not accepted in this chain, in the Lisk main chain, and here you have it back to your chain. So yeah, that happens if it is paying enough fees, but also the other situation will be if the fee is not enough to have this, it's not paying enough fee to have this return logic, and basically in that case the message will be discarded. The message will be discarded with the custom token. So this implies that, as I said before, this will only happen if something is going wrong in the given sidechain. But at least we have this return functionality that the user at least will be always using a fee above that return fee. So therefore, if something goes wrong, they will get the tokens back to the original descending chain.
And if you use the token module and don't do something that you shouldn't do, this case should actually not happen, right? Because if you send a cross-chain transfer, or if you use the API that allows other modules to initiate a cross-chain transfer, the token module will always check for you. Are you either transferring to the native chain or from a native chain? And if that's not the case, if you transfer to them, and I think it also checks from the main chain that you don't transfer native tokens to the main chain, and it wouldn't allow it.
Yeah,
I think it only allows to transfer Lisk to the main chain. So this should really be an edge case if someone would modify the token module in a way that's actually not recommended and shouldn't be done.
Yeah, that's a good point. This question is quite an hypothetical question. It shouldn't happen in a normal situation, but still we have that return functionality. And the follow-up question that is somehow related, but it's touching another point, is that also how can I transfer custom tokens in the Lisk ecosystem, knowing that every cross-chain balance transfer has to pass through the main chain? Is that what we call the main chain routing in our interoperability solution. So yeah, this is a good point. Like it comes from the previous blog post, right? The interoperability solution for the Lisk ecosystem has for now this main chain routing a solution where every cross-chain interaction has to be certified, has to happen, has to pass through the main chain. But as I think Alessandro was mentioning in the last AMA, this doesn't mean that the main chain is doing anything with the tokens or whatever logic and data is in the cross-chain message. What the main chain is just being as a relayer, right? It's like, okay, I get this message from chain A, from the inbox of the chain A, and I put it to the outbox or to the chain, or the other way around. From the outbox of the chain A, and I put it to the inbox of the chain B. And I don't check what is inside the envelope, right? So if the cross-chain message is an envelope, and inside there is the custom logic, it can be custom tokens, or it can be whatever else, any other custom logic. But the main chain is just routing, is just relaying this information. So that implies that we don't care if they are the custom tokens, they are not living in the main chain anytime. It's just passing through from one inbox to the outbox of the receiving chain.
Yeah, the message is like treated like a black box, so
Yeah,
the main chain doesn't have to know about the existence of these tokens. Should we move to some recent questions which now came in via YouTube? So there's one question from Anonymovi. Can I send Lisk tokens to Sidechain and in the Sidechain send this Lisk to another account? That's the first part. And then after all transactions sent back to the Lisk main chain. I think for the first part, my understanding is that the question is if you always have to send to your own account or if you can send directly to someone else's account. Like if I own some Lisk on the main chain, if I can send it directly to for example, to your account on the Oracle sidechain. So
or otherwise you are limited to your own account in the sidechain, right?
Yeah,
that's the
so this is in general possible. So you select both the receiving chain and the receiving account for a balance transfer. So you can directly send it also to someone else in a sidechain.
Yeah, and also maybe in what the last part of the question says the send Lisk to another account. Once that this Lisk or these tokens were transferred to the receiving chain, they can in the receiving chain they can be transferred to any other account or used to any custom logic that this receiving chain has, right? So it's not like like they will have as this receiving chain has the token module implemented, it will have all the functionalities that the token had in the sending chain. So there is no limitation in that way. Like you can send it to any other account, and once that it is in the receiving chain, it can be sent to other accounts and however you want to use it. Yeah.
And maybe then regarding the escrow, for example, if I send 100 Lisk to you on the sidechain, the main chain will just remember, are there 100 Lisk to send to, for example, this Oracle sidechain, and the main chain doesn't store to which account this has been sent to, but just stores there 100 Lisk in this Oracle sidechain, and then they can come back and be sent to any other account.
Yep.
So that you just have also the scalability benefit that the main chain doesn't need to know about like the exact token ownership in the sidechain. There can be many Lisk balance transfers that happen in a sidechain, and that don't burden the main chain with any overhead. And the main chain just stores kind of the big picture, how many Lisk tokens are in a certain sidechain.
And I think this also goes in the direction of answering the second question, right? This is after all these transactions, I understand, after all these transactions that happen in the receiving chain, can we send back, or how do you say it, like send back to the Lisk main chain? And Yeah, I assume once again, like in the specific case of the list token sending to a given sidechain, these lists can be transferred to any account and used in any way in the receiving sidechain. And after all, one of the accounts can decide to send part of this list back to the list token, sorry, to the list main chain um, by the given functionality of the token module. Like that's the typical, like the standard functionality of doing a cross-chain transfer in and out your native chain to a certain sidechain, and inside the sidechain to any account. Yeah, and the other way around, returning those tokens.
Then maybe the next question, also from YouTube, from Constantino Fritura. The question is, will these tokens support functionalities similar to ERC20 tokens on Ethereum? And here, if you look at the ERC20 contract and the functions that you are required to have to follow the standard, I think they pretty much correspond to also the functions that this new token module offers. So there's a transfer function. I think there's also, I'm not 100% sure now, but I think there's also mint and burn.
I think so, yeah.
What is maybe doesn't exist in ERC20, but exists in the Lisk token module is like this locking. But then there are also like some subtle differences, like that in ERC20 you can have like what's it called, like this symbol for your token contract, like LSK. I think that's also part of this contract, whereas this is not stored like a textual representation is not stored in the Lisk token module for every token. But the basic functionalities are the same, and that also means, like, if you want to bridge some ERC20 token to the Lisk ecosystem, you could just represent them by a token that's of the token module, and then use them there. And so the basic functionalities are the same.
Yeah, that's a good point. That I would say, there's a lot of parallels, like many of the whole basic functionalities is the same. I mean, it's like basically how a token is handled in a blockchain, right? And this will make it given sidechain in the Lisk ecosystem quite easy to support or to wrap these ERC20 tokens in a token module, token representation, right, from the token module. What maybe, of course, the ERC20 doesn't have, because Ethereum is one chain, is the cross-chain functionality that the token module has, right? To transfer tokens to another chain. Because I mean, in Ethereum we have only one chain, so this is not needed. But taking out all the cross-chain logic that the token module has for the Lisk ecosystem, I think they are very similar. Like, you can make the different names maybe, but the functionalities at the end of the day are the same. Okay, maybe another question from YouTube, from the Lisk Center Utrecht user. So in the blog post, you describe a difference with Ethereum. Various ERC20 tokens are identified by a 32-byte value, while you use a chain ID and token ID as the token ID. Okay, we say you use a chain ID and a local ID as the token ID. That will be the token ID. Why did you make that choice? That's a good question. So we had I remember like also, well, especially Maxime, that he is the author of the lib. With developers, there was a series of discussion and meetings, right? To say, okay, how to best represent the tokens in the Lisk ecosystem, like what is the identifier, the unique thing to identify a token in the Lisk ecosystem. Maybe you can add later more things. One thing I will say is for the ERC20 is just like this has, I think it's just the hash of part of the contract of the ERC20 token. And from that, I mean, it's just like a seemingly random value, right? This doesn't give you any information when you look at it as from a human point of view. The first thing is like with our token ID system that we have, and for the token module that we have one digit or one number for the chain ID and the other one for the local ID. In the first look, you will see already from which chain this token, in which chain this token was minted, right? If you see a 0, you will say, okay, this is the Lisk main chain, and so on and so forth. And first, well, this maybe doesn't have like a specific value for the application, but there is always like this information of which is the native chain of the token, and in this native chain in which order this token was minted. This is maybe not like just visual information or direct information. I think another one will be that these two values are what we need. I don't remember exactly how many bytes we will need to represent in general, or most of them, but for sure it's going to be much smaller than 32 bytes, right? So the thing is, in every transfer, in every cross-chain transfer, we have to tell the receiving chain the token ID that is being transferred. And if we are using 32 bytes values, that will make the cross-chain transfers much bigger, which will make at the end of the day, the throughput of the Lisk ecosystem, the cross-chain throughput of the whole ecosystem lower, because the transactions are bigger. So for me, at least, from my point of view, we have this visual value of knowing where this token is coming from, and with the chain ID, and also the smaller size of the ID than this 32 byte value.
Yeah, I think that was already a good summary. I mean, maybe to add, like the chain ID and token ID can also be serialized, and then you have just a byte representation, which will be, as you mentioned, now like shorter than 32 bytes. It's not going to be a fixed length, because with increasing numbers, it will just become bigger. That's because of our protobuf serialization. So also the token ID in Lisk could also just be represented as a sequence of bytes. But it's just this sequence of bytes is a protobuf serialization that's composed of a chain ID and local ID. And I guess then is also the question how to present these tokens as nice as possible in the user interfaces, right? Something like having the 32 bytes shown as hex is not very user friendly. And here in Lisk, if a chain registered on the main chain, it will always have to also register a name. And so you could use this name on the front end. And with the token IDs, you could also just display the number, or maybe there are some off-chain service that allows to register a name and maybe also some symbol, like to illustrate the token even nicer, so that like when users interact with different sidechains, they can just easily with one quick look see this is this token, it's native on Oracle sidechain, and it's this Oracle governance token.
Yeah.
I think ideally users will not be confronted with a very technical representation, but just a very usable representation, which you can easily get if you know, because of this structure of the token ID, because you can always find the native chain, and then the token IDs are, or the local IDs are just a sequence of numbers.
Yeah, yeah. It's, I mean, it can be in general, as you said. At the end of the day, for the user interfaces, maybe there will show just a name that is okay, the same as happens with the Ethereum, right? With the ERC20 tokens. But at least this has in Ethereum, like, okay, you have to be sure that you are interacting or buying or whatever the right ERC20 token, and for that you need to check this whole 32 byte, like as a user. Of course, that's can be done easily, right? Just copy pasting the 32 bytes and comparing with the original contract and so on. But here with this token ID that we have for the token module, this will be easier, right? For example, you will say token 5.3 is the one I want, and that's it. Like there is only one token with 5.3 or and you don't need to check the whole, like a long byte string that doesn't mean anything for the human eye. And I mean, of course, in most of the cases, this is not going to be the situation, but I think in certain specific cases, to be sure that you are interacting with the right token, this will make it easier for the users to just in one go say, okay, I see that this is what I want to buy or I want to transfer. Yeah. Okay, what about another question? So maybe this one. So I read in the lib this concept of a terminate escrow that I think in the blog post is not mentioned, right? It's a bit more advanced. But yeah, this concept of terminate escrow. Can you give a high-level explanation what this is and why the token module needs it? Okay, so I go. So yeah, there are certain situations like, well, in the lib you can try to find this terminate escrow concept, and you will see that under certain conditions, when there is something happen with when a certain function is called, or the processing of a cross-chain transfer or so on, an escrow account can be terminated. This means that in your chain, when a escrow account is terminated, is the escrow account of another chain, right? Being it another sidechain or even the main chain. When this happens, means that this sidechain will not be able to send any more native tokens to the sidechain whose escrow was terminated. This is done basically for security reasons. The main idea here is that something happened in the other chain, in the chain that was sending us certain tokens. Something happened in that chain that is implies or gives us the intuition that the token module is not working as expected in that other sidechain, or that someone modified the token module, and as a security measure, our sidechain, our chain will cut the flow, the outwards flow of native tokens to this sidechain. So that's the idea why we have this terminate escrow concept and logic. I think, well, I cannot remember all the little cases that can happen, but basically the most normal or the typical scenario will be if this sidechain that did something wrong with the token module is sending a cross-chain transfer with some malformed data, right? Like, for example, the address, the receiving account has different length in the address, or the data field is longer than it's supposed to be. All these things will imply the termination of the escrow. Is like, okay, we know that something happened in that other chain and it's not good. But I think the most important one, the most important reason to terminate an escrow is what we were saying before, is if we see that this other chain is trying to send us back native tokens to our chain that they are more than what it was sent to this chain sidechain in the past, right? So the other sidechain somehow did something to create the tokens, our native tokens, out of thin air, and now it's trying to send them back to our chain. That's the main reason to say, okay, we can we see that you are sending more than what we have in the escrow account, and this will terminate the escrow account, and those, like, yeah, this chain will not receive any other token. The interesting thing is, like, the escrow termination doesn't imply that this sidechain cannot send us more tokens. It can still send us back the as long as the escrow doesn't go below 0, right? Can send us back our native tokens, but we are sure that we are not sending back any other token there, because we know that something bad happened in the other sidechain. And I think that's the main idea around this terminated escrow. And I think, if I am not mistaken, that was right. There is maybe another reason or another condition in the lib to terminate the escrow, but yeah, I don't know. I don't remember anymore. But the main reason will be that there is more tokens, native tokens, coming from the sidechain than we sent it in the first place.
I think one particular case, which maybe is connected to also the first question that we asked to address today, is if you, for example, are the Oracle sidechain and you receive some, I don't know, some other tokens from a, let's say, a coffee sidechain, a token from the coffee sidechain, but from some other sidechain. So you should only accept tokens from the native chain or your own tokens. You shouldn't accept some tokens that are neither native to yourself or the sending chain.
Yeah, that was the reason, the another condition that I was trying to remember. Yeah. So yeah, it's not only about your native, your tokens native to your chain, but if the other sidechain is trying to send tokens that are foreign for both chains, that will also cause the termination, because it's breaking the protocol of the token module standard.
Yeah, and it's important to mention that this is really like a fail-safe, so it shouldn't happen in a normal operation. Like if you don't modify the token module and just use the interfaces provided by it, then this should never happen. It's only a fail-safe for users if some sidechains in the ecosystem are malicious, to then protect users. Like, for example, as Ika already explained, with the main use cases, sidechain trying to create tokens out of thin air. Maybe that's due to a bug, but it's still, that means that user funds are at risk. Like if you, for example, only send 1,000 Lisk to a sidechain and the sidechain try to send 2,000 Lisk out, then you don't want that a user now sends 1,000 Lisk into this sidechain and suddenly it becomes valid that this sidechain sends 2,000 Lisk back. Then maybe this user funds, user's funds would be just lost because all the money is already transferred back, but to a different account and not to the user. So this is really fail-safe, saying don't trust this chain anymore. This chain is now on the misbehavior list, kind of, and users cannot send native tokens there anymore. Yeah.
Okay, we have another question coming from, I can never pronounce the his username, PR Semmer. Okay, this is, I will put it on your shoulders then. What
Okay.
will be what will be the incentive for a sidechain delegate if the sidechain opts out for a custom token? Would you say a custom token is necessary for an economical standpoint?
So here I assume it's the sidechain is running delegated proof of stake, because it means it mentions a delegate, and I mean if you assume delegated proof of stake for sidechain, you always need a token for your Depos system,
Yeah.
right? And for this, I think in most cases it makes sense to have a native token for it. I don't know if you would make sense to have use the Lisk token for Depos on sidechains. It could be just much more lucrative to lock the Lisk on the mainnet, because on mainnet the delegates receive block rewards, whereas on a sidechain, if you use Lisk tokens for Depos, then the delegates would not get any block rewards, but only fees for transactions.
Yep.
So I think if you run Depos on your sidechain, it's maybe a bit more difficult to incentivize the delegates without just with the fees and not with an extra native token. For proof of authority, maybe where you just the block generators in a sidechain are like a trusted group of people, maybe where then also no locking of Lisk tokens is required for some kind of voting system. I think there I could see that if the sidechain project is successful and there's just a lot of transaction load, that already gives quite a bit of income to the authorities. And this way they are sufficiently incentivized. And also going back to just like the using Lisk for Depos, I think you would have a big problem that because maybe your sidechain just is not so popular at the beginning and only 10,000 Lisk are locked, then just whale could come from the main chain and just take over all the forging slots in that sidechain with 20,000 Lisk or 30,000 Lisk. So I think for Depos to properly incentivize it, it's not good to use a token that's not native to your own chain, where you don't control the total supply.
Yeah, I think that's an important point. I mean, I know that some, maybe not Depos, but more proof of stake implementations in other projects, they don't have block reward, so they have no inflation, they have the same supply or deflating supply. But again, there is a native token that was given in an initial distribution, and from then on, depending on your balance, you will have more or less probabilities of forging the next block. But yeah, all the initial distribution and the native token there is a native token for this blockchain. So yeah, I mean, it can happen that there is a delegated proof of stake chain without rewards, but with a non-native token, as you said, that can be dangerous or maybe not a good idea. But I think that, just to reiterate, I think the proof of authority case, I think is going to be, well, it totally makes sense from an economical standpoint, right? To have a proof of authority chain where there is no rewards and there is only fees given in a certain token, and if the project is successful, there are going to be a lot of activity, a lot of transactions, and authorities are going to get, they're going to make profit out of that. So, yeah. So I would say proof of authority will be the case for a chains where are like, okay, let's have a small start. We don't need custom tokens. We just need to have this functionality, this business logic running, and make it successful.
And I think there's also like just thinking about the sidechain business-wise, I guess you could think of the you want to kind of incentivize the further development of a sidechain, also not just the validator nodes. And so you may need quite some income. Maybe the transaction fees is not enough, but there's some additional opportunities that maybe you have an NFT marketplace and there are auctions that you also get some percentage of like the auctions price, or that if you have an NFT gaming sidechain, okay, then maybe you get additional income just because you create new NFTs, and this income can be used to, on the one hand, incentivize the further development of the sidechain, the developers, the whole operations, but also to incentivize the validators, where you maybe choose to pay a certain group of people, maybe some reliable delegates from the Lisk main chain, to run your sidechain in a good and reliable decentralized way.
Yeah, it's a good point. And now that you mention NFTs, just as a heads up, the next blog post is going to be covering NFTs, right? Also by Maxim.
Yeah.
Probably in the next one he will be here talking about his own content. But yeah, the next one, just so you know, next blog post in around 3-4 weeks. This will be the NFT module and yeah, how it will work in the Lisk ecosystem. Also like covering some examples and so on.
Yeah.
Okay, maybe one last question.
Yeah.
I think we have time for one more. Okay, this one was here from before. I was thinking of a simple paying app that sends hundreds of transfers, like payments, right, from one paying account to the users. How can I do this with the token module? Okay, so here, well, basically my first idea would be, if you check the blog post, we have these expose functions like mint, burn, and one of them is transfer, right? So I would say that there will be a payment, like a custom module, payment module, let's call it that way, and it will define a certain command. And in this command, maybe there is as we want to do like from one in one go, like many payments from one account to many, there will be like an array, a list of like calling this transfer function with the different input arguments to different accounts, right, and different maybe amounts. So yeah, this command could be this custom command will be will contain like an array of transfers to all these accounts. I think that will be one simple way to do it. Of course, there will be, but to be careful, like what is the limit, how many transfers can happen in one transaction, and so on. But the token module will make sure that the paying account doesn't send or pays more money that it has in its balance, and yeah, that will be it. So with the token module, you have already this functionality to use the transfer function in any custom way that the sidechain developer will want. I think that's an initial idea.
I think I don't have anything to add. I think it makes totally sense to use the API there. All right.
Yeah. So
I think we can wrap up then.
I think there is no more new questions coming from YouTube or anything else. So yeah, I think we're good to wrap up and
All
call
right.
it an AMA done.
Then thank you very much for tuning in, and yeah, looking forward to the next AMA in about 1 month about NFTs.
Yeah.
Thank you.
Thank you very much. Ciao.